So everybody, welcome to it's becoming a tradition. We've done this quite a few times. Mike MacCana from QuickNode is a turbine WBA grad. And I remember vividly, you were so, inquisitive on the escrow process. Like you wanted to master it. It was, I remember it vividly. And you were like trying from this TypeScript background, trying to master it. And you have. Mm-hmm. We have you back because you present it in a way that is, different than what we do in program. And a lot of people need that. I mean, everybody on this call. So half our current cohort is here.
Yep. It looks like we've got like nearly 90 people here, which is amazing. So, yeah.
So I'm going to turn the floor over to you. Everybody knows the drill. Help each other in the chat. Mike will let you know when it's time for some questions. And let's have a good time. Thanks, Mike.
It's all good. Thanks very much, audible person. Great. So we're all here to build the Anchor Escrow app. Just as a little bit of background, this is probably the most important class you will actually attend. There's a saying which I heard from Jeff originally, but I'm not sure who said it originally, which is once you build a swap app, everything else is a swap app. I'm going to use the terms swap and escrow interchangeably. They are effectively the same thing. And yeah, that's a saying by almost every Solana developer. If you are going to build an auction house, then you will still need to take funds from people. You will need to store arbitrary data on chain. You will need to refund things to people, etc. If you're going to build something like a polymarket betting app, for example, you will need to do all these things. So this really covers the handling of tokens and arbitrary data. So today, I'm going to assume you have almost no blockchain experience and almost no Rust experience. I know you guys have all done the Vault before, but I'm trying to keep it really just minimal in terms of the requirements because I know you guys are new to a lot of this stuff. And yeah, so what we're going to be doing today is you're going to be building instruction handlers, which are on-chain functions that process instructions. Sometimes people call instruction handlers instructions. I like to separate the thing that's doing the actual function. I like to separate the function from the thing that it's processing. So I say instruction handlers are the things that handle instructions, much like, I don't know, like request handlers handle requests in a traditional app. We're going to store tokens in our program. We're going to store data, arbitrary data that we create ourselves, and we're going to control access to our program. Who am I? I got started in Solana, I think late 2021. I won a couple of prizes in Solana Sandstorm. Me and a buddy were trying to build a wallet. We ended up in the kind of nadir of crypto winter in early 2023. So that didn't work out. We had an investor that was about to send us a check any day now for about 4 months, which is always fun. But I ended up spending most of 2023 and 2024 at the Solana Foundation, doing a bunch, creating educational content for companies that had grants from Solana Foundation to teach to other people. So that's been spread out across the world and taught everywhere from Romania to Columbia University in New York. I'm followed by everyone you know in Solana on Twitter. So I, for whatever reason, I've just been in the space for a while, and I know most of the people in it. If you ever used Web3.js version 1, I made the Solana helpers library that you will see everywhere. It still has about 30,000 downloads a week. I made the successor to it, which is called Kite. Kite just saves you a whole lot of time when you compare it to using Solana Kit on its own or using Gil. It's really designed to allow you to do the most amount of work with the smallest amount of code. So if you're tired of setting up factory functions or just boilerplate code, just using Solana Kit or Gil, then Kite is a higher level library to just do things. Right now, I work at Solana Developer Relations at QuickNode. That's actually a new job. I've been there for about 2 months now, and I am pumping out videos and content like crazy. We just did a big deep dive into Light SVM a couple of days ago, including making a bunch of new open source code to like work with Light SVM a little bit easier. The next thing I'm about to do is tuk tuk, which Jeff is pronounced tuk tuk and not tuk tuk. You need to spend more time in Thailand having fun. QuickNode. QuickNode actually created the RPC provider business. I think there was one other company that's not around who was there in 2016. QuickNode started in 2017 and really like popularized the whole concept of commercial RPC providers. They're a YC company. YC or Y Combinator was the first investor in Uber, Airbnb, Dropbox, Google Docs. Pretty much every like big modern startup you've ever heard of went through YC. Also the first RPC provider to support Solana when Solana was brand new, and is used by really big things, big platforms we've heard of before, like Drip, Kraken, Phantom, and a bunch of others. The thing that's particularly unique about QuickNode is it has a lot of high-level libraries, most of which are actually free. So there's things like streams that allow you to like pull down and modify Solana transactions. It's if you ever have like a financial app, you want to like back test it through some previous period, it's great for that. And again, it like starts from like there's generous free limits for nearly all these things. There's Metis, which is just Jupyter Swap APIs, Pump.fun, a bunch of other useful bits and pieces. There's a price API. Almost everyone wants this, and again, you can get it for free. KYC and AML bits and pieces. We have a really good ultra low latency stake weighted quality of service system called Fastlane. And yeah, it's if you have a QuickNode account, just go into the QuickNode marketplace, sort by Solana, and you'll see all these things there. It's a really good way to kind of just get to market faster and by having to build less code. Cool. So why are we going to build a swap program today? What does it do? What is the equivalent in traditional finance? Well, swap program handles when somebody wants to swap something for something else. So in this case, Alice has a 50 USDC and 2 bonk, and she wants a little bit more bonk. And Bob comes along and he sees that Alice is offering to swap 10 USDC for 100 bonk, and he thinks that's great. So they swap. That's all fine, but what if Bob is a bad actor? The complexity here comes when Alice sends her USDC to Bob, and then Bob just leaves. So what we really want to do here is have a situation where neither Alice nor Bob have to trust each other. Sorry, that's a funny gift that's left over from the last time I did this. The joke hasn't been delivered well. If you could imagine that I did deliver the joke well, that would be great. And you can edit that out, please, Jeff. So the point is, how can we ensure Alice and Bob can swap without having to trust each other? So this is how they handle that in traditional finance. Alice sends her 10 USDC to a trusted third party, and then Bob will send his 100 bonk to the same trusted third party. And once that trusted third party holds those funds in escrow, which is where this word comes from, if you haven't heard it before, escrow means holding something on behalf of someone else. And then once both sides have completed their part of the transaction, then the third party will distribute the funds to their destinations. What you'll have noticed here is that third party has grabbed a portion, in this case 1%, of the value of the transaction. And that's pretty much how normal finance works. I bought a coffee this morning. I gave it a tip on that blue and white machine that everyone has. That's from a company called Square, and they take 3.5% of every transaction. And if you're sending money overseas, depending on the country, that can be up to 6% of the transaction. Crypto off-ramps, which I have a separate rant about, you shouldn't use. You can actually do zero. There are 0% off-ramps now. PayPal is one. It's amazing. Crypto off-ramps used to charge like huge amounts in percents as well. Yeah, this whole traditional finance is built on taking these somewhere between 1% and 6% of the value of every transaction. That's a huge quantity of money, and that's what we're going to solve today. So blockchain solves this with the swap program. Again, you can call it an escrow program, same thing. So we still have Alice, and she has 50 USDC and 2 bonk, and Bob, and he has 10 USDC and 500 bonk. we're going to get rid of the trusted third party, and we're going to replace it with a Solana program, which is also called a smart contract. Just in the same way that people in Solana tend to say things like mint address rather than contract address for a new token, we call the programs we run on Solana programs rather than smart contracts. If you're new to the space, you can sound cooler on X by using the Solana words rather than the older words. So we're going to make a swap program, and through that, Alice and Bob will swap. Great. Well, how does it work? Oh, yeah, and what are the point? Alice and Bob will swap, and both sides are going to receive 100% of what the other side is offering. It's a really big deal. And yes, there are transaction fees, but those are less than a fraction of a penny. Solana is like 0.00 something. It's a really long amount of zeros cents. And it doesn't change based on the amount of money. Alice could send $10 million to Bob, and the fees would still be the same amount. So that's a huge win for crypto. And again, the time involved here is maybe 2 or 3 seconds for transaction confirmation, depending on the options you pick. And Solana's getting faster every year, so that might even go down pretty soon too. So let's look inside this swap program. Here we have the Solana curve. And Alice has a basic Solana account. She has, a key pair. She has the private key stored on her device, and she has a public key, and she has a balance of Sol. This is the most basic type of Solana account. And Alice also has 2 other accounts that store her USDC and her bonk. So that's 2 token accounts. She has she has a USDC account whose address is made from the USDC mint address and Alice's own address, and a bonk account made from the bonk mint address and Alice's address. These are program-derived addresses by the what's it called? The associated token account program. You can also just call them associated token accounts. Same thing. They are token accounts that are associated with somebody's wallet. You might know a lot of this stuff already, but I'm being very deliberate about this stuff just to make sure that everyone's on the same page. And if it's new to you, it's probably just reinforcing things that you already know, which is always good as well. So Alice still wants to swap 10 USDC for 100 bonk. And we're going to make a swap program to handle this. So we're going to deploy that to a program ID, which is also a public key that'll be generated when we deploy our program. And it's going to have 3 instruction handlers inside. They are make offer, take offer, and refund offer. So when Alice makes an offer, she's going to run the make offer instruction handler. And the make offer instruction handler is going to create an offer account. This is another PDA that stores a struct inside. A struct is very similar to an interface in TypeScript, and the resulting object that you make from that. It's just a list of keys and values of different types. So the struct will store things like what Alice wants in return for her USDC. The other thing our program will do is take hold of the USDC that Alice is offering. So we're going to put that into an account that we call the vault. We'll store that 10 USDC there. The seeds for that will just be the USDC mint address and the offer address. We can even just store the seed just using the offer address. We don't even need to use the mint address, but that's just the way I've implemented this program. Here's a thing that I'm going to mention a couple of times because it's really important. The owner of the vault account is the offer account. So that data account where we stored information about Alice's offer, that will actually own that vault account. And you'll see later on when we want to move funds out of this vault account, we'll actually sign those transactions as the offer. Again, so the owner of the vault is the offer account. So yes, our program ultimately controls the vault account. But when our program is moving those funds, it will sign that transaction as the offer account. So Alice has made an offer, and then Alice can just go to bed at this point. She doesn't need to be awake or online or anything for the rest of this process. And, you know, there can be 1,000 or 1,000,000 Alices. It's all fine. Our program will make offers as needed. They're each going to have a unique offer ID. If someone tries to make an offer with an existing offer ID, it will be rejected. Alice can have many offers herself. They'll each have their own offer ID. But this is just the simplest case of 2 users, Alice and Bob. So Alice has made an offer. She wants to swap 10 USDC for 100 bonk, and she's done all she needs to do for this transaction at this point. So here's Bob, and Bob has, again, a basing account with some amount of Sol, and a USDC account and a bonk account, and he has a lot of bonk, and he likes Alice's offer. By the way, if this isn't obvious for people, I hope it is. If you open up like Phantom or Solflare, those PDA accounts that you see underneath Alice and Bob correspond exactly to the token accounts that you see in Phantom or Solflare. You can even open up your wallet in Solana Explorer, and you'll see the balances are exactly the same. These PDAs are your token accounts that you see in your wallet. So Bob has come along. He has a lot of bonk, and he likes Alice's offer. So what he wants to do is he wants to get that 10 USDC, and he wants to, and in exchange, he has to send his 100 bonk. So if Bob runs take offer, and again, Alice doesn't need to be online for this, our program will send the tokens in the vault to Bob, and then transfer Bob's bonk directly to Alice. And that's all that needs to happen. It's just those 2 things. And you'll actually see that in the code later on. What else? Yeah, the main point of this is that each side has received 100% of the other's offer without a middleman taking a percentage of the transaction. You know, Alice got her 100 bonk, Bob got his 10 USDC. At the same speed as traditional finance, pretty soon I think Solana is going to start outpacing things like Visa, etc. And you know that your crypto transactions will go through faster than you wait for that Visa beep when you buy a coffee, and the fees are less than a fraction of a penny. So the first thing I want to do is create data accounts, and I'm going to start getting you to code at this point. So I'm going to throw a couple of commands into the chat. The first one's actually important because the second command is actually going to dump files into this directory. So do make an escrow directory, and then the second thing is do that. Oh, wait a sec. I'm probably CD into escrow first. Can I edit a comment or delete it? In other words. Just wanted to check if people can hear me, if you can speak up, if those commands all make sense. Yep, we got some thumbs up. Great.
Can you hear you?
Great. Well, I'm sorry, I forgot to mention the CD into the directory, but definitely change into that directory because dgit does actually dump all those files straight in there for you. What dgit does is it just downloads a project off GitHub. So it doesn't include any of the Git history. It just includes the files. So if you ever need like a copy of a particular project and you don't care about the Git history, you just want to download, then dgit is essentially that. Dgits something. I actually have a copy of the project here, and I'm going to go through. I've got my many windows here. Give me one sec. Yep, there we go. I'm going to go through the structure of that project now, and I'm going to make my screen nice and big as well when I do that. Okay. So if you look in that directory that you've pulled down, this is an Anchor project that has one or more programs inside it. In this case, it just has one. It's called Escrow. We have our project configuration here. None of it's particularly interesting. It's just like, where, that your wallet is in your Solana config file, the test using localnet, boring things like that. The really interesting action happens in the program's escrow directory. The layout I've used for this is what you get when you run anchor init --template equals multiple. I might even type that in the chat, or if someone else can do it for me, that would be great. So rather than just having a big librs file, which I kind of think is pretty gross, you actually have separate directories for each of the instruction handlers. I renamed the instruction directory to handlers rather than instructions, just because I'm very, I have autism. I'm very specific about the rules, and I don't. The idea that you have an instruction that handles an instruction doesn't make sense. You have an instruction handler that handles an instruction. That's the way my brain works. So I just renamed that directory. But this is pretty much a blank project. It's a generic librs that none of these are filled in. I've got some errors in there just to do some boring stuff. But yeah, the make offer is empty. All the account structs in there are empty. The state directory is empty. The offer is empty as well. So what we're going to do here, I'll just flip back to my notes for a second. My presentation, I should say, is go and create make offer. Oh, sorry. Let me just double check something. What did I do accounts? Oh, yeah, I'm just going to do, cool. I was trying to work out if I had any bits to show you for here, but I'm just going to go straight into it. So sweet. So what we're going to do here is the first thing we're going to do is create the offer account. The offer struct, I should say. So this is the thing we're going to store on chain, which stores information about what Alice wants in return. And it's pretty simple. I'm not going to make you type. You can type if you want to. But my kind of thing here is to kind of keep this as interesting as possible. Nearly every Anchor file, you'll know, imports what's called this prelude at the beginning. If you're not familiar with the term prelude, whenever you edit a file in Rust, there's a bunch of like keywords that Rust has loaded up before you. It's called the Rust prelude. And Anchor has its own prelude that you have to manually load in. And yeah, it's what gives you access to things like account, for example, that comes from prelude. So you probably know about that already. I think in WBA or Turbine, they call them the goodies. So we're going to do a few things here. The first thing is I'll get rid of this.
Lots of goodies.
There are lots of goodies. So this is, I'll paste in what's going to be inside this struct. And these are just some really basic types that we all got from Prelude. Well, things like pubkey came from Prelude, for example. U64 is built into Rust, obviously. So we have an identifier for the offer. This is just a number. It's specified by the client, which you will think is really weird when you come from kind of traditional Web 2 programming, or anything off blockchain. But we'll actually do checks to make sure that we can't create, people can't create offers using IDs that already exist. We'll store details about who made the offer. We'll store details about the token being offered, what they want in return, how much of the token they want in return. And we'll store the bump, which is just because of the way these addresses are calculated, it's just done as a performance optimization. It will save us some time having to calculate this address later. So this struct, again, is really similar to an interface in TypeScript. And one of the things I'm going to actually add to it is, because later on I'm going to need to know how much space this offer actually takes up on the blockchain. And I'm not going to sit there calculating it, knowing that every pub key takes 32 bytes or whatever else. So I'm going to add this attribute called init space, which actually you can read the it implements a space trait, which is basically, I think size would probably be a nicer name than space, but it's a really nice way to get a total for what all this, for the space requirements or the size requirements to store all this information. So if you want to know how many bytes an offer is to store on chain because you're creating an offer account, for example, you will use this init space number in conjunction with a something called the discriminator size, which we'll do in a sec. Save that file. Make sure you don't have any warnings from things like Rust Analyzer, etc. But you should be pretty much good to go. I'm going to build makeoffer before I go through the tests, just because the client that is generated needs a little bit more of makeoffer to exist. So let me do that. I'm gonna go in and make makeoffer. All right, so we're gonna do our makeoffer now. And one of the things in so each instruction handler has two parts to it. It has a struct of accounts, which people need to specify as when they run the instruction. And it has the actual function, which does the actual work. I'm going to import a few extra things here. I'm going to import my errors, which I made a moment ago. Do I error code? Cool. I'm just not using them. I'm going to import a function called transfer tokens that I should set up in this shared folder. This is all generic code, but it's just a helper to transfer tokens from wherever they need to be transferred from to wherever they need to go to. Transferring tokens involves a call to another Solana program, so I've just wrapped that in a function. And we're going to want anchor SPL, so let's do that. I probably also, SPL tokens are the name for any token other than Sol. I probably want to make some changes here to my anchor config as well. I will want, where are we? Cargo toml. Sorry, this is a little bit zoomed in. So anchor toml. Do I have cargo toml? Do I have? I just want to make sure my dependencies are correct. Do I have cargo toml? Should be in. Is that the? Sorry, it's because my screen's so zoomed in. It's a little bit clumsy for me here. So programs escrow, cargo toml. There we are. And I just want to make sure I've got anchor SPL. Cool. So I've added anchor SPL as a dependency. This is. You will nearly always use anchor SPL. It's how you use any token in Solana other than Sol. So obviously we want to handle Bonk, we want to handle USDC, we want to handle everything else. So you nearly always want that as a dependency. Init, if needed, is the feature that allows us to create an account if it doesn't already exist. And we're going to turn that on, and the rest is just telling Anchor what version to use, or telling Rust actually what version of Anchor to use, which is the current version. IDL build as well. We want Anchor SPL IDL build. That is just another feature we're going to turn on, again, just to handle tokens other than Sol. So we have, so we've got our makeoffer instruction handler. It has the actual function, and it has our list of accounts that people need to specify. We're gonna use all the normal token programs, or all the normal Solana programs. So we're gonna use the associated token program, we're gonna use the token program, and we're gonna use the system program. So we're just gonna specify those already. We have this program type, which is kind of wraps around the associated token program. Again, we have the program type, which wraps around the system program. We have this thing called this interface type. And that's actually a way to use either the older token program or the new token extensions or token 22 program. So this allows us to like handle Alice and Bob could be swapping to older tokens or to newer tokens. They just have to be consistent about the token program they're using. I think it should actually allow swapping tokens of a different type in the same transaction, as long as they, like Alice's ATA is for the older token is owned by the older token program. But I will check that out and follow it up. We have our maker, who's the person who is making the offer. It is this account will also pay to make the offer, so we need to debit the balance, which is why we add this immutable attribute. Because they're creating this, they're running make offer, they're signing that transaction. We have the token mint A, which is the token that they are providing. In other words, Alice has some USDC. So this is, in this case, that would be USDC, would be token mint A. Again, that's an interface account. Could be older token program, could be newer token program. They're both fine, and that's just going to wrap around the token mint type. We apply a little check here to make sure that whatever the token program of the account Alice is providing is the correct one. We're going to store token mint B, which is just the token that Alice wants in return. And oh, sorry, I think I mentioned before this is Alice's token account. That's not Alice's token account. That's the type of token that Alice is providing. I should have said this is a token mint. In other words, this is USDC, or this is USDC in this case. Alice's token mint account is actually called Maker Token Account A. And again, we're going to use an interface account there. So we're going to debit Alice's token account A because she's providing that USDC. We're going to check that the mint matches token mint A. We're going to check that that account is actually owned by Alice and that the token program is the same as the token program used elsewhere. In other words, it's the same as this token program. We're going to use an offer account. So we're going to specify that. Again, it's an account that just wrapped around this offer type. We're going to create the offer. So we use the init attribute. We're going to say that Alice is the person who is making this program, making this account, I should say. The space needed will be the combination of these two things, which is pretty much the space needed for any data struct on Solana. It's always, at least using Anchor, it's always the discriminator length and the init space.
Easy for you to say, Mike. Discriminator. It's like cinnamon.
So yeah, it's the discriminator is basically just a type that Anchor actually writes out to accounts. It's just 8 bytes, and it's actually, it could even be less than that now. You can actually, it's 8 bytes by default. And so the data to actually store an offer is 8 bytes, the discriminator length, plus the size for all these things. And the way we get the size for all these things is we use this really neat init space attribute, which gave us this init space property. And that's how we got that. So in Anchor many years ago, and you'll see this in old Solana tutorials, someone would go 8 bytes for the U64 and 32 bytes for this pub key and 32 bytes for that address and all the rest of it. We don't do that anymore. We just sum these two bits of information. So that's the type that will be stored inside the account and the space needed for all the data inside. The way people will find an offer is just using offer and the offer ID. We do a little bit of extra work to turn it into bytes, but you know, it really just is the text offer and the offer ID that U64 turned into bytes. That becomes the address of this program. It's an interesting thing, by the way. If you are familiar with like cryptography in general, you'll realize that this pub key thing is actually misnamed. Sometimes it is actually a public key, like Maker is a really a public key. Token mint A is actually not a public key. It's a PDA. It's not. It doesn't have a private key or anything else like that. The Solana program crate still calls it pub key, but I've got an issue on GitHub to actually have this renamed to address. And you'll see if you use things like Solana Kit, they've actually renamed this to address anyway. And even if you look at the docs for the pub key struct, it actually says this is an address. Some of them are public keys and some of them are not public keys. So I just wanted to call that out explicitly because I know you guys are like new to Solana, and this is one of the things that I found to be a little bit like really kind of a little bit misleading. But yeah, they called it a pub key. Sometimes it's a pub key if it's actually like, you know, a regular public key with an address, you know, like your Solana wallet. Sometimes it's not a pub key if it's some kind of data account like the PDAs that store all your token balances, or the PDA we're going to be using to for this offer. So in this case, it will be made from just offer and an offer ID. That's how we're going to make the address. The final account that we need for make offer is what we're going to call a vault account. And that's a token account. Again, we just wrap it in this interface account thing. So it can be token extensions or the older token program. We're going to make the vault. The person running make offer will pay to create the vault. And we're just going to have some checks that the mint account on that token account matches the token mint A. The authority on that token account is the offer. I mentioned this earlier. The vault is owned by the offer. So authority, you'll see this word in Solana a lot. It means like the boss, the person that like is in control. So the person or the account that's in control of this vault account is the offer account. I will just briefly swap back to that diagram from a second ago. So this guy here, this vault account, is owned by this offer account. And when we move things from the vault account, we'll sign that as the offer account. And you might think that's a bit weird because the offer account doesn't have a public key. We'll show you how signing works for sending things from token accounts that are owned by PDAs a little bit later. I will go back to my notes. So we have make offer. I am going to save that. Oh yes, we need to do a couple of other things as well. We have a bit of what's called a Rust lifetime here. It just specifies how long. It's kind of like a generic for how long something should live in memory. I'm not going to go into Rust lifetimes here because that would probably be another lesson unto itself. But if I save that, it should be a little bit happier now. You can see. Also, you'll see there should be another little error a little bit later. Yeah. We need to say that that this struct will have access to some of the other parameters from when people run make offer. So we're going to create a make offer function later on, and we're going to say that this struct has access to ID because we're going to make our offer account based on the ID that someone provides when they run the make offer function. That's all happy now. We have a couple of unused functions, but the big thing is we have no red. So I'm happy with that. And then I'm going to go and create make offer. I mentioned before, make offer is just doing this. So as Alice makes an offer. Oops. Sorry, I'll leave that over here. So Alice makes an offer. It saves details about what Alice wants and then moves tokens into the vault account. So that's exactly what we're going to do now. The first part of that is we're going to have a few things that Alice is going to specify. So let's do that first. I'm going to mention a couple of arguments. Every anchor instruction handler always starts with the context. That allows you to do things like there's like context.accounts, which is all these accounts. So that is where people running this function specify all the accounts they want to use. You also do things like context.id for the program ID. I don't want to confuse that with the next one, which is ID, which is actually the offer ID. So yeah, context is just basically a bunch of information about how it's the first argument for any anchor instruction handler, includes all the accounts, but there's other things in there as well that you can also find useful, like the program ID. This ID here, though, is the offer ID that people are about to create. So it's will be specified by the client, but you'll see we do some checks. In fact, you'll see those over here. Init will actually fail if the offer already exists, and when we run our tests, we'll actually do some. We'll actually go and we'll try and create duplicate offers, and we'll try and create what else? Like yeah, we're going to do a bunch of like kind of malicious things in our tests just to make sure that they don't work. We're gonna be making offers with things like insufficient balances and all that kind of stuff. I'm focusing on the Rust today. The tests are done for you. That's why we did the npxd git. So people, when they run make offer, they need to specify all their accounts which are inside that context. They need to specify the offer ID they want to use. They want to specify how much of the token they're offering and how much they want in return. First thing we're going to do is just check the amounts. We want to make sure that they actually have at least some amount of that token. So if they say where I want 10 I want 100 bonk in exchange for 0 USDC, we're going to throw up an error. Errors are pretty boring here, so I've actually done them for you. If you look in the file error.rs, it's just another it's an enum, very similar to a TypeScript enum with a bunch of different options that we have these little kind of values, and then the message on top becomes the nice message that you see in the Solana log when you look at the either Solana Explorer or the command line if you're running these things locally. So we're just going to check that people actually have some amount of what they're people are we're not checking whether they have the amount. We're actually checking if they are that they want or that they're offering more than 0. Next thing is we're going to make sure that the mints are different, because nobody says I'm going to offer 10 USDC in exchange for 9 USDC. That would be very silly. So I'm going to do that. Again, we look at the accounts they specified, and we just make sure that token mint A and token mint B aren't the same thing. Then I mentioned a second ago, this instruction handler only does two things, which is move the tokens from the maker's associated token account into the vault. So let's do that now. I'm running this transfer tokens function, and I'm moving it from maker's token account A into the vault, specifying the amounts that they said when they ran this instruction. The mint, of course, is token mint A. The authority is in the person who owns those accounts. Those tokens that are being moved is the maker, Alice in our example. The token program is the token program that Alice specified via the context.accounts. And we don't need anything for that last option because it's not relevant here. You'll see I'm a big fan of this map error stuff. Basically, whenever you do a thing in Rust, it's going to give you a result. And you'll actually see that here. It's a result of either something or an error. And if it's an error, we're just going to throw up an error with a nice error message. You can use the question mark here if you wanted to. You could just do, rather than .map error, you could just do question mark, and it would throw up its own native error. But we kind of want to wrap it in like a nice error. So in this case, we're just saying, we've kind of assumed that the maker balance is insufficient because that's the most common cause of this error. We might actually want to be a little bit more detailed than that, but yeah. And of course, we do actually have a question mark here, but that's if the map error itself fails, which is kind of unlikely. So the question mark is okay here. The final thing this instruction handler does is save the details to make that offer account. So we need to, I just want to kind of rewind here. We need to make this with just, sorry. Oh, I can't highlight. Hang on, I'll go back to my notes. There we go. So we've just created this offer account. When we did this stuff here, we took the address of the offer account that the person running make offer specified, and we've filled it with all this information: the ID, the maker, the token mint A, token mint B, etc. So we've made this guy during make offer. The next thing we need to do is create this thing. Oh, actually, did we done the? Wait a sec. I've gone in a slightly different order, but it's okay. So I've made that guy, and then I'm going to move the tokens. So I'm going to. So we've created the offer. Oh, we've already done the transfer tokens. Sorry, you guys got to speak up if you see me doing this. I just realized I've completed it. I've completed this already. So we've done the transfer tokens. So that's moved them into the vault, and we've saved details about what Alice wants in return. So we've made this data account here, this PDA, that we can find just using the offer and the offer ID.
Hey, folks, I see a lot of people on here that are just regularly rambling on during the week. Feel free to unmute.
Yeah, jump in.
You can't be shy here. Like, I'll call your names out as people I know are jamming. So don't be shy, folks. Jump in. That's what we do. Seriously, never mind. Since when are you not talking, man? Love the chat. I mean that with love, man.
Oh, we're so happy that
Mike
joined, so we try to be, try to be nice, not to interrupt him.
I'm actually going to run around here. I'm going to run the tests, and I think after we run the tests and get make offer working, we should have a little bit of a like a Q&A type session. But yeah, we've done all the things we need to do in make offer. This is actually pretty simple, and you'll actually find that like most anchor programs are actually pretty small like this. Once you get the basics of writing data accounts, context accounts, offer, set inner, go to the offer account, set this data inside it, or moving tokens around. That handles a lot of what you need to do in most anchor programs. If you're going to make a betting app, you'll have a bunch of events that people can bet on. You're going to have maybe a instruction handler that can only be run by a certain account, and you're going to go like context accounts, events, set inner, and you'll go and say some details about the upcoming election to that account. This is how we make data accounts on Solana. This is how we move tokens around on Solana. I am going to go and run my tests now. Let me go get my terminal back up here and clear that. And it should be good. What do we got? Units of you are off. Cool. We're missing some bits. That's all right. It's I don't think it ever really if you get something working out of the box, I think it's yeah, of course. So we've gone and set up a make offer, but in librs we haven't even referenced to make offer at all. So we need to go and have you can actually see there's that error there. So if we go into librs, we'll give it all the same arguments that make offer itself has. So in other words, just that normal context, and then we'll go off to we'll go off. I've got a little extra. There we go. Cool. So we in our librs we just have kind of boring wrapper functions which take all the same arguments: context ID, offered amount, wanted amount. You'll see that here: context ID, offered amount, wanted amount. And pass them on to the individual files inside our handlers directory. We could call that instructions if you want to. I just like the term handlers as I've specified. So we've fixed that. Let's go back to our errors. Oh, it looks happy. Okay, cool. I'm just going to give it a sec to finish running those tests. Some of them will fail because I haven't implemented take offer and I haven't implemented refund offer. So I'll let it do its thing. but you should see that, oh, cool, happy things are happening. Great, this is exactly what we wanted, right? So we have a bunch of tests. I'm not going to spend too much time on the TypeScript side of things because that's pretty boring. You've probably seen it before. But
1 second, Naman's got a question.
Oh, yeah, sure.
Yeah, I just wonder why, like, let's say for transfer tokens, we're filling too much, like, parameter there. Like, so is there any practice to do, like, try into or into just to convert the struct we have? We are creating, let's say, we're doing like, so it's converted in correct format, so we don't feel it like initially. We say like we passing like context accounts, maker, and stuff. So can we use something like trying to? Is there anything in Anchor or in future maybe?
I'm having trouble understanding the question. So I understand you're talking about transfer tokens.
Yeah, like in transfer token we have like from, to, mint, authority. So we need to fill them like manually, but actually we have this struct. So we are like transferring from one struct. So what I was thinking is like, like trying to just converting them into the from the, let's say, how we call it, like from makeover struct, we can actually struct them for the transfer. So it doesn't make sense.
Yeah. I think you're trying to like use less parameters by just kind of having them come like more directly. So honestly, it's like, I mean, the way that transfer tokens is written, I guess is there's probably some the word context is overused here. What I
was thinking, like, you know, like actually
some kind of background information that's missing here. So the real function of transfer tokens is just to be a reusable function. So there's like, this takes care of just doing a lot of the boilerplate work of moving tokens around. So you'll actually see in refund offer, in take offer, we're calling transfer tokens all the time. This is actually just something I made for myself because I noticed that I was doing this work of transferring tokens all the time. So we could actually just run this like we could do all this stuff directly. Like what transfer tokens actually does is it calls the the token program has a transfer instruction handler, and all this does is make a call or a CPI, which is a cross-program invocation, one Solana program running another program, to transfer some tokens. So my escrow or swap program is calling the token program's transfer function. So we have this kind of context that's set up called a CPI context. And then we have some kind of additional bits and pieces that are needed for that. Rather than doing that directly inside make offer, refund offer, and take offer, I've just written this reusable function. So that's what's going on there. So there's you're right, we could absolutely put the CPI context, new, etc., directly inside make offer. But I'm a big fan of just like I love function libraries. I love kind of small things that I can kind of invoke when I need to that reduce the amount of code I need to look at. And then if I decide at some point in the future that I want to change them or fix them, there's one place I can look. If I wanted to modify all my transfer token functions to, I don't know, change some error messages or add some extra checks, I could do that inside this function. So yeah, it's you're right. We could do all of this stuff directly inside each instruction handler function.
Thanks.
Cool. Does anyone else have any other questions as well? I'm like totally. We've got a bunch of time. Like we're really like make offer. We've done the first instruction. The other two, we're kind of downhill from here. Could you read them out? I'm doing a bit of window management here. So with this transfer function, oh yeah, cool. Oh yeah, that's Tommy. That's a really good question, actually. So yeah, it's I can get you 2 of the 3 arrays. Oh, it's actually technically it is it's a vector of a slice, but it is a nested data structure, and I'm pretty sure there's a really good explanation of this on Solana Stack Exchange. But
Yes.
I'll show you what it is here. And it's not as complicated as what you were thinking. In what was I looking for? Transfer tokens. Where am I? Oh, sorry, it's in shared. It's this guy here, right? And actually, I want to. This is an important point, so I pay attention. I actually like renaming this thing. This is the thing that that Tommy was talking about. It's this guy here. It is a vector of a slice of bytes, right? But really, what it is, and I can kind of show you with comments, is like signer 1. Signer 1, seed 1, signer 1, seed 2, and then actually I'll do it this way. I'm gonna. Sorry, I hate all these. I'm being heckled by my AI. I really need to turn this off for demos. I should probably find out. Bytes. Yeah, bytes. Signer 1, seed 2. Bytes. And then signer 2. Yeah, that's the AI has actually helped me here. Signer 2. Yeah, cool. This is good. So really what you actually have is an array of signers, right? Oh, and move that across a little bit. There you go. Does my little ASCII art make sense here? So we have signer 1. So we have a vector or an array of signers. And so in this case, we have 2. And inside each signer, we have multiple seeds, seed 1 and seed 2. Could be seed 3, seed 4, whatever else. You know, that's yeah. There's however many we have. The whole point of a vector is it can change every time. And then inside each seed, I should have to actually check whether this is a vector or an array. It may actually be an array, so I don't think it does change over time. Yeah, I think the amount is static, but the point is that there can be the amount of seeds could be 1, it could be 7, whatever else. Inside each seed, that is stored as bytes. So bytes are effectively again a slice of numbers, basically. It's in this case, it's a big list of U8 numbers, so 8-bit numbers. So that's what you're looking at there. And so what I'm saving you from is really that outside one. This is actually written just to assume you only have one signer, which in my case is like 99% of the time of my Solana program. I only have one signer. So with that in mind, I hope that actually explains why I've called, firstly, like this comment here, only one signer seed, the PDA that owns the token account, is needed. So we create an array with the seeds. So in this case here, you'll actually see there's only, we've taken out one of the levels of nesting with that. So it's just, we have a single signer, which will be a PDA. I'll talk about PDA signing in a moment. And inside that, there is a big list of 8-bit numbers. And there can be multiple seeds. I actually like to call this thing signers seeds, plural, because there's actually multiple signers and multiple seeds inside, and each seed is a big list of numbers. So that's what I'm actually. I mentioned before, I'm really like precise with naming. I think that's really important. So yeah, there's actually multiple signers, and that's why there's multiple levels there. Apparently, if you go to like Rust conferences, there's people who wear this thing on their t-shirt. This the borrowed nested 2 arrays and then a slice of bytes, because a lot of people are getting into Rust because of Solana. And Rust people, like Jeff, were you ever a Unix guy? Like,
I wasn't. Hold on. I wasn't a Unix guy so much. You know, you got to remember when I first got into this space, it was the first time I wrote code since the 80s when I wrote. Not really.
There's like the vibe in if you go to a Rust event, like a lot of people are lovely, but there's more than their fair share of like people who are really unwelcoming to people who are using Rust for the first time. So and it reminds you of like old school Unix events.
Oh yeah,
you know, kind of the whole like neckbeard, or like if you ever met anyone that knows a programming language called Perl, it's the same vibe. So apparently a lot of like Rust people have like t-shirts with this square, you know, like two borrowed arrays and a slice of 8-bit bytes to make fun of Solana people that keep asking questions on Rust forums about what signers seeds means. So
that's
there you go.
Thing, Mike. I mean, yeah, I mean, Rust and C++ are my main languages, and they're the two that I've spent the last 5 years on.
Yeah. I think C++ is like the community is slightly more chill than the C community, but I would say also like the C community is like that. Signer sees bytes is perfect, by the way, as well. Like that's a great thing. I might even use that in future, Andrew. Someone had their hand up a second ago. They had another question. I just want to make sure I've answered them all. Tommy has raised a hand. Yeah, sure. Open queue. I think I accidentally dismissed somebody as well. So sorry if I dismissed you. Put your hand up again. Tommy, what's up?
Oh, I just had another question. So I know in this example, Bob is sending tokens directly to Alice. But would there be a situation where you would ever want to send Bob's tokens to the escrow first, and then the escrow sends the tokens to both parties as like the intermediary holder?
It's like a thing called a good example of that is a thing called a fan out wallet, for example. So that's actually there's a really good example about this from the Tuk guys, which are they actually oddly enough my cell phone company uses Solana. So there's a company called Helium, which they kind of have a phone network, and but they also give you 5G base stations that strangers will use. They'll connect to your base station and then they'll reward you. And then they have this like fan out wallets, right? So one of the things you could do is actually you could like accept tokens from somebody and then distribute them out, like say like 40% goes to this account and then 20% goes to these 3 other accounts or whatever else like that. Like you can kind of slice and dice this however you want to. Really what we're just showing here is just an example of how to like hold tokens in your program and send them out to somebody. Does that answer the question?
Yeah, that's perfect. That makes sense. Thank you.
Is there somebody else had their hand up before? I just wanted to make sure that I didn't. I saw a little dialogue here and I went, go away. It's probably asking about Gemini, but I realized it was somebody putting their hand up.
Yeah, I did want to ask quickly about what actually this one topic of the escrow. So I was imagining that the base of the escrow is having 2 accounts where it keeps the 2 tokens, and then once they are both there, then it gives them away. But from your introduction at first, 1 is missing, so there's only 1.
Yeah, that's totally correct. And it's really, we could actually do it that way. Like we could actually kind of wait for Bob to send his tokens. I'll pull the diagram back up as well. But the thing is, we really just don't need to do that. Like,
okay, I see. So it's not because it's not crucial.
We could have Vault A and we could have Vault B. Like we could absolutely make this, but in the kind of general spirit of like what's the word? Just kind of removing unnecessary code. We're not doing it that way, because this is as well, because you're going to remember, like, if any, I'll kind of go into this with take offer in a second, but if any part of like take offer fails, so like this is so Bob runs take offer, and our program transfers tokens from the vault to Bob, and then maybe this fails right here. That means that none of the changes will be made to the blockchain. Like we don't need to, if any part of Bob running take offer fails, there'll never be a like the situation you see on screen right now, where we're like halfway, we've done this, but we haven't done that, that will never happen, because a Solana instruction is atomic. It either succeeds or it fails. So if, say, the instruction was able to move the tokens into Bob's account, but moving the tokens that Bob's offering to Alice failed, then the whole instruction would fail, which means the whole transaction fails, which means nothing changes. So this is kind of really the whole concept of like transactions. Either everything that's part of something completes, or none of it does. A really good example was like when you go to an ATM machine. Hopefully your balance is deducted and you get a bunch of cash. If you get a bunch of cash and your balance isn't deducted, there's a problem. If your balance is deducted and you don't get any cash, that's also an issue. So yeah, that's what we mean by atomic. All of take offer must succeed, all of make offer must succeed, all of refund offer must succeed for this to actually work. Did that answer the question? I just wanted to make sure.
Yes, thank you.
Cool, excellent. Should we go on with take offer? Sweet, excellent. The vibe is let's do take offer. So I'm just going to remind you, like, I mean, you've seen it a second ago. All we're going to do here is Bob takes the offer and program transfers the tokens, and we move them straight back. So let's go back into our code. And you'll see this is actually pretty damn similar. You just see the direction of things is a little bit different. So let's go into take offer. We import the anchor prelude as always. And we're going to start with the tokens that people need to, the accounts that people need to provide when they run take offer. I'll also mention some other bits and pieces we're going to use. So I'm just going to pull in my error codes because they're useful. We're going to reference the offer struct we made earlier. We already have the anchor prelude. We're going to mention the associated token account program, and we're going to be doing more of this token interface stuff, which is, again, like little wrappers around the older token program or the newer token program. Our take offer struct is going to start with all the normal programs. So yes, we're going to use the associated token program, and we're going to use the system program, and we're going to use whichever the older or the newer token program, depending on what the user specifies. This take offer is invoked by Bob. Bob is the one who's signing this transaction, so we're going to call him the taker. And because Bob is signing this transaction, he'll pay the transaction fee. That's why we have this mutable attribute here. The maker will also be involved. So we're going to put that there. Well, I'll also get rid of this warning about the lifetime not being there. Info, by the way, is basically a raw Solana account. Solana calls it the Solana program library that sits underneath Anchor calls like a raw Solana account an account info object. I hate the name account info. Don't ever program anything with the word info. It means nothing. Like it could just call it account or raw account. I would love that. Info is like so meaningless.
So reference to bytes? No, you don't like that?
Yeah, I don't know. Like it feel like, yeah, I get that it's the data inside an account, but it's still just call it an account or an account data or something like that. We're referring to the token mints of, in other words, USDC and Bonk or whatever else. We're going to have the taker's token account A. So this is where Bob is going to receive the tokens that Alice is offering. And that account may not already exist. So we're going to run init if needed. And Bob, who's the taker in this case, will pay to create it. So he's going to pay to make an account where he's going to receive his tokens from Alice. And we're just going to check that the mint for that token account is the mint specified, and the authority is Bob, and the token program is the same token program that whose account we specified. we have the taker's token account B. This is where Bob is going to send his tokens to Alice, for example. And again, this is going to be mutable because we are going to change the balance of it. And what else? We're just going to check that it is indeed using token mint B, that it is in fact, like Bob's bonk account in this case, that the token program is either the older or the newer program. As long as it's consistent, that's fine. Now, Alice is going to need to receive her tokens from Bob. So we're going to call that maker token account B. That is, if this is all confusing, I'll just get back to the diagram for 1 second. Keynote. This one here is, so that's Alice. She's the maker. This is Alice, maker token account A, and this is maker token account B. This is Bob, he's the taker. This is taker token account A, and this is taker token account B. So I hope that is clear. If not, you can replay that part of the video. But so maker token account B is this one here, and we're going to create it because maybe Alice didn't have any bonk. Maybe she had 10 USDC and she never has had any bonk before. So we're going to create that account if we need it. Bob's going to pay to create the account, and we're going to make sure that account is in fact a bonk account, that the mint is sent to the bonk mint. The authority is Alice. That's going to be Alice's account. And the token program is the same token program consistently that we've used elsewhere that matches the token program that Bob specified. What else? Oh, we'll actually need to reference the offer as well. So that will be involved in this transaction. By the way, another thing that I didn't realize when I was like really early in my Solana journey is why, or the benefit of us having to specify the accounts we're going to use for every single transaction. Because in other blockchains, you don't have to do that. You can just, just move stuff around and it's great. The really cool thing about this is that while, say Bob also has, I don't know, some PYUSD, right? And there's a separate transaction where somebody's sending Bob some PYUSD. At the same time, we're modifying this while Bob running the takeoffer, the transaction with Bob running takeoffer is modifying his USDC and bonk account. A separate transaction could be modifying Bob's PYUSD account. The reason why we specify the accounts when we run Solana transactions is so that Solana can modify different accounts at the same time. That's also the same reason why Solana stores different information in different accounts, so it can be modified in parallel at the same time. So one of the things those validators do when they're processing transactions is look and find out whether transactions are overlapping or not, i.e. whether they include any of the same accounts. And if they're not modifying the same transaction, if they're not modifying the same accounts, they can actually be run at the same time, which is one of the reasons why Solana is fast. So yeah, that's basically a little bit of extra work when you're calling these functions, because you need to specify all the accounts as part of the parameters, context.accounts. But there is a huge benefit, which is that Solana is really fast. So we have the offer account. We're going to change it because we're actually going to close it down once we're finished with it. I'm going to just do some checks on it. And we can find the offer account by just using the offer, the text offer and the offer ID. And again, the bump is the offer bump. The final thing we'll do is, because we're also using the account when Bob runs take offer, is we'll specify that. I'm conscious of time here, so I'm going to speed up, but you've seen most of these checks already. Obviously, this is mutable because we're taking the tokens out of the vault. Now, this ties in with some of the stuff you were asking during after we finished make offer, which is to do with the signer's seeds. So the first thing I'm going to do is set. I need to sign a transaction as the offer. So even though this program is our swap or escrow program, it doesn't own the vault. The offer owns the vault. So the account seeds for the offer vault is just simply the text offer and the offer ID. And also you specify the bump that was used to create the address for the offer account. All that extra work there is just like the B and this 2 LE bytes. It's just converting that into bytes. So it's basically saying the offer account seeds are the text offer and the offer ID as bytes. And we're also going to specify the bump. With that, we're going to wrap this in a sum. This is basically just kind of a little, a way of, we're going to use this effectively. You'll see it in the transfer token section in the next moment. We need to have a Rust handles optional parameters in a slightly different way than TypeScript. So that's what the sum is doing that there. It's just effectively saying this is a value we're actually going to provide this time. It's used for calling transfer tokens. Then we actually call transfer tokens to give the tokens in the vault to the person running take offer. Specify they're coming from the vault. They're going to Bob's USDC account. We're taking the amount from the vault. The mint is the USDC, and the owner of the vault is the offer, and the seeds are the seeds we've specified. And we're going to close the vault because we don't need it anymore. I'm going to call another helper here, which is called close token account. You'll see it in shared. It's not particularly interesting. It just takes care of doing some extra work for closing token accounts. Where is it? What does it do? So yeah, it runs close accounts and does some little checks, and it can close like PDA accounts owned by PDAs and accounts owned by regular users. That's kind of nice. But it's generic code, so it's not, you can cut and paste it, and it's what's the word, like it's not particularly important to understanding the syntax of calls to close an account isn't particularly important to learning an escrow, and you can, next time you need to close an account, you can use the same code. And then finally, so we've transferred the tokens out and we've closed the token accounts. So let me hold on a second, because there's two transfers here. One is from the maker's associated token account to the maker's associated token account to the vault. Is that from maker's token account? It's moving it to the. Oh, sorry, I'm in the wrong file. Sorry. I hope I haven't edited the wrong file, have I? Sorry. Oh, I think edit. Sorry, I was just in the shift up. Z. Let's say that looks correct. Cool. Sorry, I opened make offer rather than take offer there. So we've transferred the tokens from the vault to the taker, and we've closed the token account. The final thing we need to do is do that last part, which somebody asked about during the break, which is transfer the tokens from the taker straight to the maker. And that should be it. There's a bunch of red there that I'm going to fix in a second. Oh, I've got to specify my options here for take offer. So take offer is, it's just literally context. Here we go. Cool. Underscore context versus context. And did I import all my, no, I need to import transfer tokens. Where are we? I could just do yoink. There we go. Fixed. And then yoink. I could use fix with AI, but I actually know where it's coming from, which is my error code. How's error code? How's transfer tokens? What's that complaining about? Transfer. Error code, failed vault withdrawal. Oh, maybe I actually added an error code. Hold on a sec. I'm going to go check my errors. Oh, I've got some extra error codes I've added. I can see that. Hold on a sec. I'll send you a repo after this, but it's literally you can even just create these yourself. I've added a couple of extra errors for failed to withdraw tokens from vault. I've just made a pretty error message there. So I'll save that. That should be happy. Close token account, import that. And no more red. So that looks good. So I'm going to run our tests again. Before we ran make offer, we firstly made sure that we can actually create an offer. We made sure that it didn't work. We tried to reuse an existing offer ID. That's just checking that init works, because init will always fail if you try and create an account that already exists. That it fails when it has insufficient token balance, etc. If somebody tries to say I want USDC and I'm giving USDC, that seems wrong. You can just give someone USDC if you feel like throwing some away. And if somebody specifies silly amounts as what they want. So what we're going to do now is run the test for a take offer. So that's going to firstly create an offer, then try and take it, and then check the balance of the account. And also we're going to try and create an offer and try and take it when we don't have the right amount of tokens. So we'll run anchor test. That will build our program and then run our test. This will take a moment. And I'm gonna, that sounded like a little thing there. So I'm gonna jump back to the chat for a sec. Where are we? Zoom should be, no. Sorry, I'm on not my normal desktop, so I'm doing a little bit of extra window management today. Where are we? No, this is Google Chat. Did somebody have a question? I heard a little alert there.
Yeah. I thought, well, while it's loading, if there was an opportunity to ask a question. So as we know, like in Token 2022, we have additional hooks which are runnable.
Yep.
So do we need like additional validation or assertion to be done on the take? Because like it fires something. So I'm not sure how it's working, but it could do something.
Yeah, definitely. Right? Like that. If you had a transfer hook, you would absolutely want to check that the transfer hook is basically you would check that the accounts that the transfer hook is modifying have been modified in terms of how you expect. It's that's entirely reasonable. It's just really another extension of the existing tests. You'll go and calculate the addresses of the accounts that the transfer hook will be modifying, and then you'll check the balances of if they're token accounts or the data inside if they're data accounts.
So like, you remember we have like a require assertion before we get into like we assert the context and then we do the transfer. So is there anything we can do to check about the hooks? At least if there is a hook, then we will do like additional assertion.
Let me think. Because you would check that in the token mint account, because the transfer hook is enabled on the token mint account. I don't know what a transfer hook would look like on the like on a token mint. I just haven't done that much with transfer hooks before, but it would be another aspect of it. You could check it with require or any other like normal like Rust mechanism, and it would be some aspect of the token mint, in the same way that any other extension is. So it's if you're doing token metadata or whatever else. So it would be a property of the token mint. I'm not sure on the exact syntax, but I can go and chase it down. There's probably some good docs on. I know if you go to solana.com /courses/developers, they have one on transfer hooks, I'm pretty sure, for token extensions. QuickNode has a bunch of documentation on transfer hooks as well, but it will be a property on the mint, like any other token extension.
Awesome, thanks.
Cool. Anyone else? Any more questions?
Hi, Mike. Can I speak?
Yeah, sure.
Okay, so based on my understanding, the taker is taking the token from the vault, and in the other transaction, in the other instruction, in the same transaction, he sends the other token directly
it's actually just one instruction. So there's multiple.
Oh, really?
So so each so look at take offer, for example. So that's the account struct, which is pretty boring. This is just like each instruction handler. This directory could be called instructions. Again, I like calling the functions handlers. So each of these instruction handlers has multiple functions inside, but they are still one Solana instruction. So when I'm actually, in fact, if you go into the tests, these are like, you can go see, Alice has some amount of token A and all the rest of it. It's all pretty boring. We're making some token mints, we're minting some tokens so that they can have some initial balances. And you'll see in, say, create test offer, that's a good example. That's just a test helper. We go and make our, we create a make offer instruction, which is literally just using the client that I use Kadama, you could use Anchor, you could use whatever else. So we're creating a make offer instruction, and we only have one, when we run our transaction, we only have one instruction inside, which is our make offer. So we could actually have a separate instruction inside for, say, the memo program, and we could like write something out to the Solana logs describing the transaction. We could add, there's actually an interesting thing recently, which is I read about yesterday. Somebody has a, like you can add an instruction at the beginning of your transaction. So the really cool thing about Solana is all these instructions can be to completely different programs. So you can actually make a transaction that calls the token transfer program, that then goes and calls the memo program, then calls like Lighthouse to check the balances that are what you expect and make sure you didn't get rugged. I was reading about something yesterday that actually is an instruction you can put at the front of your list of instructions, which says that if this transaction is being processed at the time when a validator that I don't like is the leader, then fail.
Wow.
And that it's like basically there's some people who like basically there's some word there's I don't want to badmouth anyone on video, but there's some people feel that some of the validators are doing like sandwich attacks or front running, etc.
Yes, exactly. That's what actually I was thinking about.
Yeah, it's actually really cool.
If instructions are separate, I can, like, for example, I can take that instruction and use it for my advantage because it's signed already. So I can actually use it in another transaction before that transaction executes.
The signature is unique, and you can't reuse signatures across each. The signature is a signed version of that transaction, and you can't reuse the same signature across multiple transactions. There is a thing called a durable nonce, which is, if anyone is from Britain, you're laughing now, and we can just keep that as a private joke amongst ourselves. But there's a thing called a durable nonce, which is like permission. It's like it's a forever signature, but everyone's moving away from them because they're a terrible idea. And I think wallets are even like starting to tell people don't create a durable nonce. It really was. People used to do it to make like Solana SaaSes where you can have like repeat billing, etc. Now, but I think like there's better technologies out there for repeat billing. Sphere has some cool tech for that. But yeah, generally, not as a rule, signatures are not reusable across transactions.
Okay, that's new to me.
The durable nonce is the only like exception to that. But yeah, the kind of the cool thing that people are talking about here is this idea that you can have a single instruction to multiple programs, and a lot of the security programs like Lighthouse and like the one I was reading about yesterday, whose name I can't remember. I think it's called Gateway or something like that, or something like that. Or Validator Gateway or something like that. But you can actually have like you have an instruction that before your other instructions that checks the validator and fails. Then you have an instruction after your other instructions that checks the balances your token accounts and make sure they're what you expect. You can actually combine functionality from different programs to do cool things. And so you have a lot of like transactions that reuse existing programs that are good at what they're doing to perform particular tasks, and then add, instructions to, your program to do the things that are unique to you. I might want to do some cool things like maybe I want to make a multi-sig account with squads. So I'll have an instruction that makes a multi-sig account with squads, and then maybe another one to the token program's transfer instruction to go and put some tokens in that account or something similar.
But I was not thinking to reuse it. I was thinking to use it before the transaction gets executed. Like I pretend I'm a validator and can use that instruction already in a separate transaction before the legitimate transaction gets used.
Yeah, so there's Solana, so the people, validators do actually use transaction information to do, there are bad validators out there who are front running. Again, I don't want to name it, but there's actually a site which you probably find on my Twitter account retweeted by somebody else. But yeah, so there is definitely people who do MEV, and they can see that, incoming transactions, etc., and basically effectively front run them. And there's also a thing called backrunning, which is looking at transactions as a form of market data and effectively looking at it as low latency access to what's happening on the market. Solana doesn't have what's called a shared mempool like Ethereum had, so it happens less on Solana, but it does definitely happen. This thing I was talking about yesterday, it's in my Twitter account. It's called validated gateway, etc. That's one way to actually ensure that your transaction is not processed by that validator, for example. So yeah, and that works by injecting a new, effectively a validated check instruction that runs before the other instructions in your transaction. And again, the rule for if any instruction fails, the whole transaction fails.
Yeah. Thank you so much.
No worries. Anyone else?
Yeah, I had another question. In make offer, when we are initializing the offer account, and we are deriving the account with the seeds and the ID, the offer bytes, can we also use the third field to use the maker key to derive it, and that way
we could. I think originally
the person making it.
Originally, I actually had the maker in there. The thing is, it really depends whether you want to have offer one Mike's address and then offer two Tommy's address. Those could be separate offer accounts, or you can just have offer one and offer two. It's really the whole of Solana PDAs is a type of key value store. These seeds are how you create the key. So it's really a program design thing. My mentality with any kind of programming is if it can be removed, remove it. It's from the guy that wrote The Little Prince, Antoine de Saint-Exupéry. And it's perfection is achieved when there's nothing more to remove. So I think originally, first time I wrote it, I actually had the maker's key in there. But then I thought I don't really need it anymore. You'll also see as well, some people make indexes, people make PDAs that are also indexes, where they just store, maybe you want a big list of all the offers that have been made by a particular account. Or here's a better example. Maybe you're making Polymarket and you wanted, you have events which have lots of outcomes, and outcomes have lots of bets, right? So you have an event struct, and it has outcomes, which is a vec of addresses, or pub keys. And then each outcome, Trump wins, Biden wins, whatever, is its own, is there's an outcome struct for all of those. And then for all the people that bet on Trump or for Biden, you have another vec of pub keys or addresses, which are, the fact that, Tommy placed a bet on whoever he bet on. that's cool. You have this like events. One event contains many outcomes. Each outcome contains many bets, but you might want to look up the bets by the individual. You might want to quickly access all the bets by an individual. So like RPC providers like QuickNode have like cool indexing systems you can use, but you can also just build your own indexes using PDA. So some people do that as well. Or you can actually index using like Postgres if you really like Postgres. People are used to that on all the blockchains because they're a little bit slower, but you can also just do on-chain indexing in Solana. It's like literally just making a PDA of like bets for Tommy, and I can see that you bet on the election, then you bet on the Pope, and that's the, you know, different bet IDs, etc. So it's really just a program design consideration, the seeds you use for a particular account.
Okay, yeah, that totally makes sense. So in this system where we have like the global IDs, basically, is there any risk of like race conditions where
like collisions, etc. Race conditions, so these are a PDA is always specific to our program. So this is just inside the program ID of whatever my inside this program. So they're not quite globals, they're globals for my program. If somebody does try and create an offer that has an existing offer ID, it will fail. And the offer ID on the client side is just generated by a random number. But if it wasn't generated by a random number, you know, my offer ID is 1, it's actually going to throw an error. So that's actually the one of the first things I test for. And that's actually given to us for free by Anchor when we added that init attribute to the offer ID. It said, make this, and it fail if it doesn't exist, or fail if it doesn't exist already. That's one of the rules for init. So we kind of get it for free just by using Anchor. This is like, there's a lot of things that you kind of would otherwise be building yourself that you get out of the box with Anchor. Actually, there's Jacob Creech had a great tweet about this yesterday, saying like, everyone has their own stuff they prefer. Some people like Web3.js. Some people like raw Solana kit. Some people like high-level libraries like Kite. Some people like light SVM for testing. You know, whatever else. I recently got into light SVM. I really like it. But one thing that we all do is we like, I'd say maybe 90% plus people use Anchor because no one wants to write deserialization and serialization. No one wants to write like the thing that takes an incoming instruction and finds the right instruction handler to run it, make offer, take offer, refund offer, etc. It's called an entry point function, and it's boring. No one wants to, you know, write their own version of init that goes and makes a nice failure if the account already exists. Because if you did write that yourself, unless you're really good, it probably won't be good as what Anchor gives you for free. So like, you know, use Anchor. Like 2 years ago, people were like, I had a discussion with colleagues at the Solana Foundation. Like all our docs say, here's how to do native Solana. And then they would like 2 chapters later be like, oh, by the way, you didn't need to do any of that because you could just use Anchor. Like, why don't we lead with Anchor? And like literally all of them were personally using Anchor by default. And then we decided to like lead with Anchor. And I think one of the things that Foundation's done really well recently has been realizing that, you know, like Foundation, you know, like Foundation don't make Anchor. Anza doesn't make Anchor. It's made by a guy called Acron, who's essentially an open source developer. But it's like, it's not a project of a particular company or anything else like that. But it's the thing that people use. So we need to kind of, you know, like Foundation and everyone who's making content on Solana needs to meet people where they're at now. There's really cool things about Pinocchio, but Pinocchio still does less things than Anchor. No one wants to generate a TypeScript client to, you know, based on an IDL. That's boring. You know, Pinocchio might have that now. It didn't have it a couple of months ago when I looked. So I like Anchor is great. It gives you a lot of things for free, and making sure that you can't reuse an existing offer is one of them. So that's a very long answer to a simple question, but I hope it was a good one.
Awesome.
Yeah, I mean,
Thank
look,
you.
the one thing that's important to know about like the Pinocchio anchor thing is this, anchor makes sense for most use cases. Pinocchio makes sense for fewer. You're going to start to see a lot more Pinocchio concepts and tools in Anchor. Anchor V2 is going to have a lot of Pinocchio in it.
Mm-hmm.
I mean, the one thing that about Pinocchio is as soon as you use the entry point, you're saving about 70 to 80% of CUs just from the entry point.
Yeah, that is like, it is, like it's what I hope is that Pinocchio will be there in like maybe like 12 months or 18 months. That would be amazing. There is a lot of work on it and it's an ANSA project. So I think, ANSA probably want to control more, like ANSA now have their own like DevRel team. I think ANSA probably want to, if I were ANSA, I would want to control more of the Solana developer experience rather than having like the Solana program crate be like a side effect of Anchor, which is the thing people actually use. So what I would want to do if I were ANSA was make Pinocchio as accessible as possible and kind of do more things out of the box and, make them all optional. So if you don't want those things or if you want to replace them, you can, which feels very ANSA.
That is the path they're taking. I mean, we're working with FIBO, and we actually will be running our second Pinocchio program starting on Monday. So, and a lot of the focus is on that DevX and that optionality.
Yeah, I mean, I'd even love to join you because I think, I like the idea of being 10x faster. I don't actually mind writing my own code, and I can I've started publishing Rust modules recently. It's like what I would do if I was learning Solana, I would probably not just stick with Anchor. You have a limited amount of time, and I would make sure that you know Anchor very, very well before you push into anything else. That's, I think, probably the most efficient use of your time. It's the same way as if you're writing some front end code, you could write your own front end framework, or you could just write React, and maybe React is pretty old and dated at this point. Virtual DOMs, everyone knows they're a little bit slow, but it's like you have a limited amount of time. Spend it on the thing you're building. Don't spend it on recreating a lot of boilerplate stuff. I want better, I want better Solana programs. I want more efficient Solana programs. So I personally I'll keep an eye on Pinocchio. I might contribute to Pinocchio if I feel that it's worth it. But if I was learning Solana, I would just stick with Anchor for now. Cool. I want to point out as well, I think I was scrolled up to the wrong part, but yeah, all those takeoff are success. All those takeoff tests are passing. Refund offer, I'll just go through real quickly for you because it's boring and you've seen 90% of it already. We're going to do our imports. We have our token program and our system program because we're using them. Refund offer is if Alice, by the way, makes her offer and no one comes along to take it. So Alice is going to sign this transaction. We're going to deal with the, I think in this case, USDC would be token mint A. Alice's has a maker token account A, which is where we're going to refund the tokens back to. We're going to look at the offer account and we're going to use the vault. And all refund offer does is return the tokens from the vault to the maker's account and close the vault and return the tiny bit of Solana back to the maker. So it's just another transfer from the vault, but you'll see the destination is Alice's maker token account A. Then we close the token account and then we're done. We have some nice failed refund transfer and failed refund just some nice kind of error messages which expand into more descriptive things, failed to close vault during refund, etc. That's all refund is. We'll also need to jump into where are we? librs and just make sure, is there anything else we need to specify? No, we don't actually. We don't need to specify. There's no extra options for refund offer. I'll also point out to the crowd, this is one of the other things that I didn't find intuitive. If I think I was running a function called refund offer, I would go, well, what's the offer I'm refunding? Where am I specifying that? And the answer to that is in context. It's inside context.accounts. I'm specifying the offer account that I want refunded. So like if you don't see a parameter that you would expect in an instruction handler, the answer is it's actually inside the accounts that you need that people specify when they run that instruction handler. So when people run refund offer, the offer that is being refunded is determined by whatever account they specify right here. If I run the tests now, give it a sec. These are, by the way, I have light SVM tests. I made a video about this recently. By the way, subscribe to QuickNode's YouTube channel. I'll show you something really cool. This is actually, when did I do this recently? This is, hey, all the tests have passed. I just did this stupid confetti thing. But if I scroll up before all the confetti, in fact, I'll remove the confetti. Give me a sec. As an anchor.toml, get rid of the confetti on passing all the tests, and you'll see it runs and they all pass now. I have a really good video called 25 times faster anchor testing with light SVM, and I'll turn the sound off just to give you a demonstration here. So I had a repo that originally took 93 seconds with using Web3.js, and I'd already ported it to Solana Kit. Because Solana Kit uses things like web crypto and big ints and all these things are like built into JavaScript now, it is a lot faster. So I was already starting from 25 seconds. The first time I used light SVM, those tests went down from 25 seconds to, I think, about 3 seconds. And then after that, I got rid of a bunch of duplicate code, and the results were 0.9 seconds. So light SVM, like I'm not a big, if someone tells me something's going to be a little bit faster, I don't normally care. But light SVM is 25 times faster. I have a copy of this repo, which is linked to from this video. And like it is the Anchor Escrow, but the tests complete in 0.9 seconds. So anything that's an order of magnitude has me immediately interested. That's kind of my hope for Pinocchio, that it's basically as good as Anchor. It does all the things Anchor does and is like 10 times fast or 10 times more efficient. Yeah, like if you're interested in this stuff, like my role at QuickNode is just entirely producing really useful Solana content. So if you like that kind of stuff, you can always find more of it here as well.
Awesome.
Cool. Yeah, is anyone have any more questions? I think we've got a couple minutes left, or some love hearts. Thank you very much. If you want any, if you're interested in finding out what the name of that thing to kind of blacklist bad validators, or you want to see cool things about light SVM or Pinocchio, I'm on X. This is me. You can also send me feedback about this session. I'm always interested. Like the Escrow program, as we said before, is really like the key to learning Anchor. So I always want to get better at it. I've taught this to a lot of people at this point. But I always think there's like more to do, like things that we can kind of get rid of in our explanations, or things that can kind of take us there faster, or better names we can use for things. So if you follow me on X, DM me, my DMs are open. I would love feedback for this. And yeah, if you also follow me on X, you'll see everything that QuickNode is doing in the Solana space. You know, I can get you promo codes. I can get you, you know, like a lot of, you know, like first access to a lot of cool tech that doesn't have documentation or videos yet. And I promise everything will be animated. Everything will have like a equivalent in, you know, TradFi, so you actually understand what it is you're building. And yeah, I want to thank Jeff for this opportunity to present to you all. There's as I said before, there's a lot of talent that has come through WBA, and you guys are part of that. So that's amazing.
Thanks, Mike. And look, let me give a shout out to QuickNode, because I mean, we we have a lot of our people with it once they graduate and they're starting to look at getting full-time jobs and getting some of those wild take-home tasks that you know about.
Yeah.
Who need a free tier to be able to do these tasks. And I'm going to tell you right now, folks, there is no better free tier. And look, the paid tiers and all that stuff beyond are excellent as well. They've been around since day one. They're massive. They are, the quality of their tooling means that their tagline isn't how great their customer service is. The free tier is the best free tier on Solana for devs that need to not be rate limited and have to go buy something that they maybe need once or twice.
Yeah, it's also just like when you're making something new, I need prices for tokens. Like, come on, guys. So like, there's so much, like you can literally just go into this this marketplace inside the QuickNode dashboard, and there's so many things you can enable for free. Where really like we have a bit of a reputation for like generous free tiers, not just for the actual like RPC product, but for all for most of these things you see in the marketplace, like prices or anti-MAV tech, or what else, like just token data or swaps, anything there. You can just flip things on inside the QuickNode marketplace and get a bunch of extra APIs that will solve you from, that will mean that you don't have to build those things yourself, which means you can get to market faster. If you are, like, my other recommendation to people, because I know that when you come to the Solana, you don't really know anyone. It's kind of hard to kind of raise funding, etc. If it's not clear already, I think Jeff probably made this apparent. Finish WBA, build a thing, win a hackathon, get funding. When I was trying to like do this, I won a hackathon 3 years ago, and the funding kind of wasn't there at the time. It was in this kind of crypto winter. But it is now. Like if you go and if you like get a place at Breakout, then like Coliseum will just take you into their accelerator and start introducing you to investors. And investors are starting to come to these accelerators to be like, cool, this is like deal flow for the smartest teams in Solana. So if you want to make crypto your full-time job, learn how to build the Escrow app so you know how to make things on chain.
Everything
finish WBA, build something for a hackathon project and win.
Yeah. Cool. All right, let's wrap this, folks. Mike, thanks so much. And this was last minute, and you are usually very hard to nail down. So thank you, and thanks to the QuickNode team for freeing you up today. If I don't see you, good luck in October, but I'm sure I'll probably bump into you before then. Everybody, enjoy the weekend. You know me, touch some grass, eat some good food, hang out with some friends, and we'll see you on the flip side on Tuesday.
Excellent. If you, by the way, if you take that address from the MPXD Git as well, and if you remove the like beginning kind of the end part of it, which is like the branch name, you'll see the completed project as well. So you can get the whole thing on GitHub. I think the one on GitHub as well has the light SVM tests. So yeah, go subscribe to QuickNode's YouTube channel. I go through like why light SVM is amazing. It's good fun. We're doing something with Tuk next. I think Tuk almost deserves to be like part of the standard learning process for people on Solana. I love having like automated tasks, etc. It's a really good time to learn things on Solana as well. Like there's so much amazing tech that's coming out. Yeah.
Awesome.
Cool. Have a good one, guys.
Y'all take care, yo.